see if you need it. Okay, so here's how you do that. You type in your equations, you hit second trace, you go to the intersect, and the first curve, it's just you see what you're on. I'm on the x cubed function, so you can go anywhere around the point of intersection. And the second curve, you're along the second curve, so anywhere around that intersection, hit enter and guess, you'll get -1, 3. All right, so here's what you do. You type in your equations. So 2x, use the caret key and then the cube, and you use the right arrow to get down, right? Minus 3x plus 2. Whoops. Catch my. Okay, minus 3x plus 2. And then negative x squared minus 4x. And then you hit graph. And if your viewing window is weird, you can just hit zoom 6. That's your standard viewing window. Okay? Now, to find the intersect, you guys, we said we go to second trace, which is like your calculate button, right? Second. Okay, is it freezing on me? Okay, there we go. Okay, and then we go down to intersect. And then mine says left bound, right bound. Yours will say first curve. So you go along whatever that curve you're on, you hit enter. And then you go to the next curve, it'll say second curve. And then you just go somewhere close to the intersection and hit enter. And it will give you, oh, you know what, sorry. I need to make sure I do mine right. And you hit enter and you'll be fine. So like this is like my left bound, I have to do my right bound, but yours will just be the curves, and your intersection should be -1, 3. Did we get that? Yeah. Okay. Awesome. Okay, moving on. So today we're going to P6 in your packet. Please go there. We'll come back tomorrow. Hopefully, I will remember my graphing calculator. MacBook. So today we're talking about asymptotes and holes on graphs. And did you guys know that you can cross an asymptote? We're going to talk about that today. So rational functions are of the form, you know, they have a numerator and denominator. So they're polynomials, right? They have to be polynomials. That's the key. So like if it's, when it comes to like, if you make it anything weird like absent value or anything, that'll be weird. Okay. All right, so here's some rules for asymptotes and holes in graphs. So these are the things you want to fill in your blanks. If you cancel a factor in the numerator and denominator, it's a hole, okay? If you cancel a factor, that creates a hole, okay? It looks like, meaning like it looks like there should be a value there, but there's not. We have to put a hole. If anything else is left in the denominator, you set each factor equal to 0 and solve, and those are vertical asymptotes because your denominator can equal 0, right? You guys remember vertical asymptotes, like that dotted line, right? Okay. So that's asymptotes and holes, okay? That's pretty basic. We're going to go over all of this. Horizontal asymptotes are the weirdest, okay? If your degree of the numerator is less than the degree of your denominator, so like if you have, like, I don't know, x cubed over x to the 4th, right? There's a horizontal asymptote at y equals 0, okay? If the degree of your numerator is equal to that of your denominator, this is where it gets weird. So let's say I have like the same thing, like x cubed over 2x cubed plus 7, I don't know, right? So that I can't just cancel those. You'd say your horizontal asymptote is at a sub n over b sub d. So that's your, it's like the number, the coefficient in front of the highest exponent here. So in this case, 1. and the leading coefficient in front of the denominator, which is 2, right? So that would be, a horizontal asymptote here would be 1/2. Does that make sense? That's what that is. And then if the degree of the numerator is greater than the denominator, we're just gonna say there's no horizontal asymptote. That can become a slant asymptote, but we're not gonna worry about this, okay? All right. So, let's go ahead and try them, okay? So keep your graphing calculator handy. I'm also gonna have you guys draw all these on, or sketch them on your graphing calculator to get that practice in as well. But before we put this in on our calculator, we're gonna state all vertical asymptotes and holes and horizontal asymptotes. So I think this is, I'm sorry, I have different directions. It should be B, and this is C, and then D is to sketch. Okay. All right, so we have to factor everything, okay? So we're going to factor our numerator by using the X method, okay? So this is the numerator. Multiply to 1 times -10, so -10. And add to middle term of -3. So you guys know what does that? -5 and 2, right on. And we divide by, leading coefficient is 1, variable the middle term is x. So really just x. Bottom of the top, x minus 5 times x plus 2. Now, we have to factor our denominator, if possible. Can we factor the denominator? Yeah, see nods. What is it? X squared minus 4 is a, what's the word? Difference of squares. So it factors as x minus 2 times? Yeah, x plus 2. Okay, can we cancel any factors? Yes, we can cancel the x plus 2's. It's all multiplication. Now watch it, I'm gonna color code this here, because, so I can cancel the x plus 2's. Do you remember what it says when we cancel a factor? What does that create? It creates a hole, right? So, I'm gonna note right away that I have a hole at x plus 2 equals 0, because that's a factor in the denominator that's canceled. So really I have a hole at x equals -2, okay? So the coordinate that you typically find at x equals -2, the y value is just gonna be a hole, okay? When you graph it. All right, let's keep going. So my function turns into x minus 5 over x minus 2. Also this was part B, we already answered part B. Okay, the next thing, we need to state all vertical asymptotes, right? So vertical asymptote is when the denominator equals 0, right? So, so part A, like for a vertical asymptote, the denominator equals 0. So we say x minus 2, that's your remaining factor. You would say equals 0, so x equals 2 is a vertical asymptote. I'm using VA as my abbreviation. Cool. Do we have a question? Okay. Now, we're going to find our horizontal asymptote. So for part C, the horizontal asymptote is found by comparing the degrees of the numerator and denominator. So, and if you need to reference that box right now, you can. So we're going to compare the degree of the numerator versus the denominator. What's the highest degree in my numerator? It is x squared, 2, right? That's my highest degree, x squared. And my highest degree is also 2 in the denominator. So when they are equal, our chart says, hey, we have a horizontal asymptote at y equals a sub n over b sub n, so, or b sub d, sorry. So then a sub n is your leading coefficient of the numerator, and b sub d is your coefficient of the denominator. So my coefficient of the numerator is 1, and my coefficient of the denominator is also 1. So I have a horizontal asymptote at y equals 1, right? So horizontal asymptote at HA at y equals 1. Okay? And now I'm going to go ahead and sketch these on our graphs. But before I do, are there any questions? I know that was like a lot. Yeah? Okay. So let's sketch our asymptotes. Y equals 1 is a horizontal line. So make sure you sketch that in. And then we have a vertical asymptote, x equals 2. That's a vertical line, right? So at the x value of 2, we draw a vertical asymptote. And now, here's where I'm just going to say, let's graph it and sketch the graph, okay? Your graphing calculator is meant to be a tool to help you see what this looks like. I'm not going to make you find like x and y intercepts and all that. I did that in my like trig classes, but so go ahead on your calculator. What's most important, I want to make sure you know how to type this in. We're going to type in the original equation, okay? You always type in the original equation. So when you type this in, do you understand that you're going to need parentheses for the numerator and for the denominator? Because whenever you're dividing, you have to divide quantities. If you just type it in straight without any parentheses, it's not going to graph it right. Yes.
You can just use the fraction button.
Or you can use your fraction button. If you have, if you go to, yeah, I think you can go to alpha y equals, right? And you can type in a fraction, and you can do that. Or I usually just use parentheses, so. We got x squared minus 3x minus 10 divided by quantity of x squared minus 4. Okay, double check. And go ahead and hit graph. Everybody got it? Any problems? I'm not hearing anything. Okay. So basically, we just want to translate what we see on our graphing window to the graph that's down here. So you have, do you guys remember what these curves are called? What's the word? It starts with H.
Hyperbola?
Nice, Billy, hyperbola, right? So we have, that's like your parent function, 1 over x. So it looks like we have our graph kind of goes through, does it look like x equals 6 to you or something like that? I don't love how this graphing calculator is set up. I'm just going to graph it on here. Yeah, it looks like it goes through 1, 2, 3, 4, 5, 6, x equals 6, right? So just make it look like that, and so we set up, like it's like this, it's a hyperbola. Actually, I should probably flatten that out a little bit. Because it goes to the horizontal asymptote but not past, okay? And then the other side is you have to factor in the x equals -2, there's going to be a hole. So if you look, you just want to put like it's slightly above, like it's in between 1 and 2. So I would just put a hole maybe about there. Does that make sense? At -2, that looking where it is. And then you draw the rest of your function guided by the asymptotes, right? So it's going to go like that. You won't see asymptotes on your calculator, so you have to put those in. And we're done. We've sketched the graph. Are there any questions? Okay, yeah. You ready to try one? I think we definitely need to try one. So go ahead and do the your turn problem there when you're ready, and I'll come around and assist as needed, okay? Does yours say, hold up, does yours say over 2x squared plus 8x?
It's 2x plus 8.
Can you fix that for me and make it 2x squared plus 8x? Sorry about that. 2x, I do wanna do this. Normally I kinda go with whatever it is there, but I do wanna do this one. 2x squared plus 8x, please fix that. Okay, go ahead.
Really old.
Okay, I'm gonna go over this then.
So it looks like it should be in the 90s.
So,
If you plug headphones into it, either nothing's gonna happen or it's gonna make really loud screaming.
we factor everything. This is a difference of squares, x minus 4x plus 4. All over GCF 2x, and you get x plus 4. So check it, you can cancel the x plus 4's, that creates a hole, right, at x plus 4 equals 0, so there's a hole at -4. What's left is this. So for part A, my vertical asymptote is when the denominator 2x equals 0. Oh, shoot. Thank you. Sorry guys, I just realized I was trying to think. There we go. Did that help? Okay. So vertical asymptote when the denominator is 0, x equals 0. Then, this is what most of you are confused on, right? Let's talk about the horizontal asymptote. The horizontal asymptote, you compare the degrees of the numerator versus the degree of the denominator. The degree is like your power. They're both x squared, right? So the degree of the numerator equals the highest degree of the denominator. So when they're equal, your paper says under asymptotes that the asymptote is at a sub n over b sub d. A sub n is the leading coefficient of the numerator, in this case 1, right? And b sub d is the leading coefficient of the denominator, so 2. So it's going to be a horizontal asymptote at y equals 1/2. Does that make sense? Okay, that's when they're equal. It's easier when they're not equal. I just chose equal because I know those are the hardest ones. So you put in your asymptote at 1/2, so just kind of like that. Y equals 1/2, that's your horizontal. Your vertical is at y equals 0, so that's right here, like this. And then we have to graph it. So you pop it in the calculator, the original equation. You got 10 minutes. I just figured it out. And then you just kind of copy what you get. Okay, so then we should have, it looks like it goes through like x equals 2, I think. And just you're guided by the asymptote, so you can't cross those. And then wherever the value for x equals 4 is, it's like about there, right? You put a hole. Just gonna put a hole there. And then guide it by the asymptotes. Okay? Good? Okay. All right, on to next example. We got one more example and then a practice problem. So, these are just applications of hyperbolas. So like hyperbolic functions. Did you guys know that they're in like nuclear power plants because it's a really strong structure? I showed this to my honors class last year, but yeah. So it's a really strong structure. Dulles Airport is a hyperbolic function, which is kind of cool. So anyway, bridge designs. So, cool stuff. And the Mars rover. But now we're going to talk about how can I cross an asymptote. Listen, you can only cross a horizontal asymptote in a very specific instance. So when you cross an asymptote, you can only cross it close in because asymptotes are concerned about behavior on the ends, right? They're talking about end behavior, like going to negative infinity and positive infinity. So if you cross the asymptote close in, that's fine, okay? So only the horizontal asymptote can be crossed. So let's take a look. This is an example that crosses it. So let's go ahead, factor everything. Well, this factors to 3x plus 1 over difference of squares, x minus 1x plus 1. Does anything cancel? No, nothing cancels, right? So you're not going to have any holes, right? If nothing cancels, there's no holes. So part B would be, sorry, this was B. So part B, there are no holes because no factors cancel. Okay, if you need to write that down. And then let's move on to vertical asymptotes. Vertical asymptotes. Where are my vertical asymptotes? X equals, do we know? Set your denominators equal to 0. 1 and negative 1, yeah. So 1 and negative 1. It's each of these factors would be set equal to 0. So 1 and negative 1, are we good? And then our horizontal asymptote, this is a little bit different from our other one. Our horizontal asymptote, we compare the degree of the numerator and the degree of the denominator. What's the highest degree in my numerator? X to the first, yeah, 1. And then the denominator? 2 is your highest, x squared. So, the degree of my numerator is less than the degree of my denominator. What does the chart say about that? It says, if n is less than d, the horizontal asymptote is y equals 0, right? So, bless you. So, there is a horizontal asymptote at y equals 0. Good? Easy peasy. So now we're going to sketch in all of our asymptotes. Sketch, sketch, sketch. Y equals 0. And then our vertical asymptotes at negative 1. And 1. Okay, now go ahead and graph this on your calculator. Oh. Did you get something like this? So do you see how the middle part crosses our horizontal asymptote? You see that? That's okay because it's close in behavior, and the horizontal asymptote is about these guys tending towards negative and positive infinity. Okay? So let's just sketch what we have. It looks like there's a 0 just to the left of 0 is the origin. So I'm going to plot that there. And then it looks like kind of an x cubed function, right? That's kind of looks like a parent function there. So you just kind of sketch that. And then you sketch your hyperbolas on either end. There's no holes, so just use the asymptotes as like a guide. We're just sketching, just a rough sketch is fine. And something like, oops. That. Okay. And that's it. What do you guys think? Good? Okay, ready to try the your turn problem? We have it at 19, right? Perfect time. All right. So, as your closure, today go ahead and do your turn 2. Okay, here's the your turn problem. You would factor the difference of squares in the denominator. And you cancel the x plus 3, so there is a hole at x plus 3 equals 0, so x equals negative 3. The vertical asymptote, you set your denominator equal to 0. So x equals positive 3 is your vertical asymptote. And for the horizontal asymptote, you compare the degree of your numerator to the degree of your denominator. And that degree in the numerator is 1. Degree in the denominator is 2. So the numerator's degree is less than the denominator's degree, and our chart says that there's a horizontal asymptote at y equals 0 when that happens. If they're equal, then you need to do the coefficients over each other. But nice and easy. And so your graph, you would sketch it on your graph, and it would look like, so alpha f1, we can put a fraction in. I don't know why it's being silly. Okay, there we go. We put x plus 3, or you'd have to, if you don't use the fraction bar, we can use parentheses. Mine's giving me trouble, so x plus 3 divided by x squared minus 9. You graph it, and we have our graph here. Just make sure you put your whole at -3 and copy the graph. We're good.